Good afternoon. I'm Todd Crickmore, and today we are going to complete a geometric proof. First of all, what is a proof? Well, a proof is just a statement that uses logical evidence to prove that something is in fact true. And when we complete geometric proofs, it's like either solving a puzzle or navigating a maze. We have a starting point, we have an ending point, but we don't necessarily know what steps are required in between to get to our destination. But fortunately, in mathematics, we have the benefit of thousands of years of work and trial and error by mathematicians such as Euclid and Pythagoras that have given us certain tools to use to construct our roadmap when we put together a proof. And these tools are called theorems. Now, what is a theorem? A theorem is just simply a statement which has been proven demonstrably and irrefutably true by previous statements. And let's go into a specific situation for a proof. Say we want to prove the congruence of two triangles. Well, fortunately, Pythagoras, Euclid, and other mathematicians have given us a series of theorems which we know can prove the congruence of triangles. There are 5 of them, in fact. There are the angle-side-angle theorem, the angle-angle-side theorem, the hypotenuse-leg theorem, the side-side-side theorem, and the side-angle-side theorem. Each one of those will irrefutably demonstrate that two triangles are congruent. The puzzle, in fact, is to determine which of those theorems will work in each particular case. And that's the fascinating thing about geometry, is that every single proof is a different circumstance, and you never know which theorem is going to work best for you. In some cases, multiple theorems will work. But let's take a look at this specific instance and see what evidence we have, and then use that to determine what our best case for proving the proof is. So here we have triangle ABC and triangle CDA. We're given statements that side BC is congruent to side DA, and that's demonstrated in the drawing. And then side BC is also parallel to side AD, and that's indicated by these symbols on the drawing. Our objective is to prove the triangle ABC is congruent to triangle CDA. Well, let's go ahead and build a flow chart or a roadmap of all the steps we need to prove that these triangles are congruent. We start by listing our statements, beginning with side BC is congruent to side DA. That was given to us. We also have side BC is parallel to side AD. That was also given to us. And then let's take a look at the final step, proving that triangle ABC is congruent to triangle CDA. Well, that's our final destination. How do we get there? Well, let's go back and take a look at what we have. We have two sides in common that are proven congruent. We have these same two sides parallel to each other. I also see a transversal line which passes through those two lines. And I also know that whenever we have two parallel lines, a transversal passing through them will create opposing sets of angles which are congruent, such as angle CAD and angle BCA. I know that these two angles are congruent to each other by the alternating interior angle theorem. So angle BCA is congruent to angle CAD. So now I have a common side shared by the two triangles, and I have a common angle shared by the triangles, which are both congruent. So we have an angle and a side. But then I also know that this same transversal which passes through those lines forms a third side that is shared by both triangles. So I'm going to say that side AC is congruent to side AC. And the reason for this is the reflexive property of congruence. Just as when you stare in a mirror and you see a reflection of yourself, side AC is reflected across the transversal and is concurrently shared by both triangles. So now we have a side, angle, and another side which are proven congruent and shared by both triangles. So I can now prove the triangle ABC is congruent to triangle CDA by the side angle side theorem. Thank you very much. I hope you have a great afternoon, and I look forward to seeing you again.